This is our half wave rectifier circuit. This is our AC power supply. AC power supply positive terminal connected the diode positive terminal and negative terminal connected with resistance, and the resistance is connected the AC power supply ground line. And this is our CRO for measuring the output waveform as well as input waveform. At first, CRO self test or calibration. This is calibration peak to peak 2 volt and 1 kilohertz frequency. This is position selector. This is peak to peak 4 unit into 0.5 volt, 4 into 0.5, that is 2 volt, and frequency time period 2 unit, 2 into 0.5 millisecond, that is 1 millisecond. F is equal to 1 kilohertz frequency. Calibration done. Then the CRO positive and negative probe connected the load resistance RL. This is our half wave rectifier output, and measuring the value amplitude is y axis, then y axis division is 1 2 3 and 2 small division 3.4, because one big division is 1 unit, in between one big division 5 small division, so small division value is 0.2, 3 big division value 3 unit, and 2 small division value 0.4 unit. 3.4 into voltage per division 2 into 2, 6.8 volt Vm. Output Vm is equal to 6.8 volt. And time period, one full cycle time period is 1 2 3 4, x axis 4 is color here. Time period is 4 into 5 millisecond, 4 into 5, 20 millisecond. T is equal to 20 millisecond, F is equal to 1 by T. This is our output waveform. And now see the input waveform. Red probe connected to the input. This is our input waveform. This amplitude is 1 2 3 4 5 6 7 7.4, 7 big division and 2 small division, 0.4 value, 7.4 into voltage per division 2 volt, voltage per division 2 volt. Then the value is 7.4 into 2, 14.8 volt, and time period 1 2 3 4, 4 into 5, 4 into 5 means 20 millisecond. T is equal to 20 millisecond, F is equal to 50 hertz, 1 by T. This is our input waveform. Now measuring the AC voltage and DC voltage using multimeter. This is our multimeter, and set the voltage level, DC value, and measure the voltage across the load resistance. This is our DC voltage. Measuring the DC voltage or AC voltage using multimeter. Feed this load across this load resistance and note down the value. VDC is equal to 2.04 voltage, VDC is equal to 2.04 voltage, 2.04 voltage VDC. This is our VDC. This is our VDC voltage, 2.04 voltage. Now VAC, rotate the meter to AC signal. Now VAC is VAC is 2.06 voltage. VAC is 2.07 voltage. VAC is 2.07 volt. VAC is 2.07 volt. VAC is 2.6 voltage. VAC is 2.60 voltage and VDC is 2.05 voltage. VAC, this pointer is AC, ADC, VDC is 2.05 and this pointer is VAC. VAC is 2.60 or 57 voltage. 57 voltage, 2.57 voltage. This is our half wave rectifier. Now full wave rectifier. This is our full wave rectifier. Another diode is connected here. This is full wave rectifier using center tap transformer. One positive supply is connected at positive terminal, another positive connected to the another diode positive terminal, and two diode negative terminal are shorted, and this point is load resistance point, and load resistance other point is connected to the power supply ground terminal. Now the measuring and show the output wave from this CRO. This is our full wave rectifier output. Full wave VM is, output VM is 3.2 मतलब 3.4. output VM is 3.4 into voltage per division 2 volt. 3.4 into 2 6.8 volt, and time period 1 full cycle. This is 1 and 2 division, and time per division of is 5 millisecond. 2 into 5, 10 millisecond. T is equal to 10 millisecond and F is equal to 1 by T. Now measuring the AC voltage using multimeter. AC voltage and measuring DC voltage. This is our AC voltage for full wave rectifier. AC voltage is 2.14 volt, and selector should select DC. This is our DC voltage, VAC, and VDC DC voltage 4.11 volt. And input waveform is same. Input signal is same.